Let's continue talking about our mechanisms of breathing. Part of every breath that we take, whether we are inhaling or whether we are exhaling, part of that air remains in our trachea and our bronchi branches. And we refer to it as our anatomic dead space. Now, we've said that our tidal volume is around 500 mils of air, meaning that we normally inhale 500 mils of air and we normally exhale 500 mils of air. So if we look right here, let's say that this is our lung, and let's say that our total lung capacity is 2,700. If we go ahead and exhale 500 mils of air, then we should have 2,200 mils of air within our lungs. So let's say that those two blue parts right here are representing the air that we are going to exhale. So as I said, we normally exhale 500 mils. So as we are exhaling those 500 mils, 150 out of the 500 that we are exhaling, as you can see, remains within your trachea. It's not going to be pushed out of your body, like it remains within your trachea. So that means only 350 mils of the fresh air that you just exhaled is about to completely exit your body. But as we said, we exhale a total of 500. So, and I only exhaled 350 fresh air out of my alveoli. So the rest, which is 150, is actually coming from the stale air that was already in your trachea. So you push out of your body, you push out 150 mils of stale air plus 350 mils of fresh air out of your alveoli. Same thing, when you are inhaling and you want to inhale your regular tidal volume, which is around 500 mils of air. So when you are pushing 500 mils of air into your lungs, one more time, you are pushing first the stale air that was already in your trachea, and that's 150, and then you're going to push in fresh air, fresh atmospheric air, which is going to be around 350. So again, that's going to give you your 500. So you're pushing in the stale air, plus you're pushing in some fresh air. And then the rest of the fresh air, the 150, is going to stay behind in your trachea. And so at all times, you are going to have 150 mils of air within your trachea and your bronchi. And at all times, when you think about it, you are always exhaling part of the stale air and part fresh air. Same thing when you are inhaling, you are going to be intaking some fresh air, plus you're going to be intaking some air that was still in your trachea. Our total pulmonary ventilation is basically the volume of air moving into and out of our lungs every minute. And so to calculate that, we take our ventilation rate, so basically how many breaths we take per minute, and we multiply that by our tidal volume, and that would tell us, again, how much air is moving into and out of our lungs every minute. Now, if we want to calculate our alveolar ventilation, then that would tell us how much air is reaching our alveoli, how much fresh air is reaching our alveoli. And so therefore, we have to subtract the air that was already in our trachea, that anatomic dead space. So to calculate our alveolar ventilation, we would take our ventilation rate, so again, how many breaths we're taking per minute, and then we would multiply it by our tidal volume, but we gotta subtract the stale air that was already in our trachea, because again, we are trying to figure out how much fresh air is moving into and out of our alveoli. So that's why we have to subtract out the dead space volume, which, as I said, it's usually around 150 mils of air. When you hear of someone having an anaphylactic shock, that's usually caused by severe allergies, and that's when individuals are not going to be able to breathe. And the reason why they're not able to breathe is because due to that allergic reaction they're having, their bronchioles are constricting. And so there is no airflow to the lungs, and so therefore they start to suffocate. And now the reason why they're going through bronchoconstriction is because histamine is what's being released, and histamine causes the bronchioles to constrict, and that's why when someone is having an allergic reaction, they would tell you to take antihistamine, or you would quickly inject yourself with your EpiPen, and it's called EpiPen because it's epinephrine. And so epinephrine is known to actually relax the muscles, and it would help you dilate your bronchioles. You would go through bronchodilation, and you would start to breathe one more time because you are dilating those bronchioles, allowing the air one more time to enter into your lungs. Now, the parasympathetic nervous system is also known to cause or to contribute to the bronchoconstriction. And whenever you are constricting your airway, by the way, you are increasing the resistance. The sympathetic nervous system is actually going to contribute to the bronchodilation. And again, when you are dilating your airways, you are decreasing the resistance.